Not right this moment, yeah. Alrighty, so here we have vectors. Has anyone done these in physics? Adding vectors? No, okay, basically what we're doing is we're adding things that not only have a magnitude, 10 plus 10, but also have a direction. So if we have, for these examples, it's force, but we will actually, when we're doing it in the context of what we're doing, we will be using bond polarities, which we'll do after break, okay? I know, right? But it works the same, okay? So if you had 10 newtons of a force pointing to the right and you had another 10 newtons pointing to the right, how much would you have in total? 20, and which direction would it be pointing? To the right. So hard, yes? That's why I thought this would be a nice thing to do today. Okay. Now what if we had 10 newtons pointing to the left and another 10 newtons pointing to the left? What would our total be? 20 to the left. What if we had 10 newtons pointing to the left and 10 newtons pointing to the right? Well, you can imagine if I push this way with 10 and if I push that way with 10, which way does it go? Nowhere, because those forces cancel each other out. And that's what we're going to be looking at a lot of when we look at bond polarities, okay? So they cancel each other out. Now, what if I have 20 to the right and 10 to the left? 10 to the right, yes? So you can see this portion here cancels. And what we're left with is 10 newtons going to the right. Straightforward enough? Excellent. So I'll let you guys do those ones once we're done here. Here now we have adding vectors in 2 dimensions. So that was in 1 dimension, just 1 line. What we're going to do is we're going to place the head of the arrow, of 1 arrow. So that would be, which end of the arrow is that? The head? It's this part, right? With the arrowhead. I know this sounds stupid, but you know, I've had people ask me, they're like, what's the head of the arrow? So where's the tail of an arrow? Yeah, the tail of the arrow is over here, okay? So that would be the tail of the arrow. And we're going to make sure that the head of this arrow is going to touch the tail of the other arrow. You don't want head to head, you don't want head to tail, or sorry, you don't want tail to tail, you want head to tail. Then we are going to draw what is called a resultant. And it is the result of the 2. It is the net result of the 2 vectors. And we do that by attaching the tail of one arrow to the head of the other arrow. And it doesn't make a lot of sense when you say it, but when you see it, it will make a lot more sense. So how is this relevant to polarity? You will be using the resultant of multiple bond polarities to find the net polarity of the molecule. But for now, we're just going to do vectors as they are. So let's think of it like walking. We have a walking forward arrow, and then we have a walking to the right arrow. Yes? So if I walk forward from point A to point B, and then I walk to the right from point B to point C, I have actually just traveled from A to C, yes? So my resultant will be A to C, because that is the same as walking from A to B and then B to C. So if I had a force for example, and that force was pushing up and it was pushing to the right, what would the net result be? Diagonal, yes? It's pushing up and to the right, diagonal, and that's what we see here. We see that lovely little diagonal force. Does it matter which way we put the arrows? You notice here I've put the up arrow first and then the across arrow second. Does it make a difference if I do the across arrow first and the up arrow second? No, because you end up with the same resultant. What happens if you accidentally connect an arrowhead to another arrowhead? Well, let's talk about this little journey that you would walk on. If we start at X and we walk to Y, then we would have to like teleport, yes, to Z and then walk to Y, and that just doesn't make any sense, does it? We're not really taking a journey then, yes? Same problem if you put two tails together, yeah? We could walk from W to X and then teleport back to W and walk to Z. And then the question becomes, you know, which was our final destination? Was it W? Was it X? It's just a mess, right? It's not working because that's not the way we do vectors, okay? And what happens if you draw the resultant arrow in the wrong direction? This is like where you've just closed the loop. We go up, across, and then back down, okay? Is the result of walking the solid arrows the same as the result of walking the dashed arrow? It's exactly the opposite. So you can tell if you've drawn the arrow the wrong way because it will not take you to the same final destination, okay? So here we have some examples. This arrow, you can either first go down and then go up, or you can first go up and then down. Either way, you end up with the same resultant, which is slightly tilted up and to the left. Okay? And that's it for today. And you have like 6 exercises. Boom, done. Not a bad lesson, hey? Little. Pequeño. Petite. My grade 9s cleared me out of Santa Bucks, I'm sorry.